Welcome to 10 minutes CS. Today's Leetcode problem is 1 to 91 sequential digits. It's a medium problem. An integer has sequential digits if and only if each digit in the number is one more than the previous one. What does this mean? This means that let's say we have an integer as 1, 2, 3, 4. This will be the sequential digits integer because each number is greater than the previous one. What if we have 1, 2, 2, 3? This is not a sequential digit integer because the next number is not greater than the previous one. It should be strictly greater than, not equal to. And we have to return a sorted list of such integers in the range low to high inclusive. For example, if we have low as 100 and high as 300, we can have digits such as 1, 2, 3 and 2, 3, 4, which lies well under the limits and is sequential as well. Now let's look at the example number 2 and try to create the output sorted list. So we have low as 1000 and high as 13,000. If I have to make the list of sorted integers, if I have to create one sorted integer with sequential digit which is greater than 1000, I can think of a number which starts with 1. Now for example, if I'll start with 0, that will definitely be lesser than this number, right? Because the initial 0 will be excluded out and the rest remaining remains the given number, right? So I'll start with 1 and then I have to add sequential digits. Now if I add 1, 2, this is less than this. Now 3, this is still less, and 1, 2, 3, 4. Now this is greater than this. What if I just add 5 to this one? Is this under the limit? Yes. Now what if I add 6 to this? Is this under the limit? No. So this we cannot add. Now let's add the next numbers. Previously I started with 1, now let's start with 2. So 2, 3, 4, it is still not in the range, and if I'll add 5, this is under the range. What if I add 2, 3, 4, 5, 6? Now it has exceeded the limit, so I'll just exclude it. Similarly, I can start with 3, so 3, 4, 5, 6. Is this under the limit? Yes. Now if I'll add 7 to it, it will exceed because this was 2, now this will be 3, and we have to start with 1. 4, 5, 6, 7, then 5, 6, 7, 8, 6, 7, 8, 9. Now if I'll add 7, 8, 9, can I have another number which I can add here? So it is sequentially increasing as well. If I'll add 0 or any other number between 8 or even 9, still it won't make a sequentially increasing integer, so this will be excluded. What all are we left here? We can just have them all and we can see. So 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 7, so on and so forth until 1, 2, 3, 4, 5. So this was the one that we created, right? Now let's think about how we can implement our intuition. Here we tried to create numbers starting from 1 until the first digit is 9 and keep on adding the next bigger integer, right? So for this, we know that we can definitely run a for loop which starts from 1 until 9, which will be the starting point for our number, right? And to get the next number, we can just check the previous number by, for example, we can have previous as num modulo 10. So this will give us the previous digit and we can just add 1 to it, right, for our next digit, and we can simply add our next digit to it, right? And we can increase it by 10 so that it becomes the for example, if we are adding it to the ones index, then this should go to the tens index, similarly to hundreds, etc. So we can just multiply it by 10 and then can add our next digit here. So on and so forth. We can keep on incrementing and adding these until we are out of bound, which we can definitely check with an if condition, right? We can check if we are in the bound or not. If we are in the bound, then we can add it to our answer. Otherwise, if not, we can just simply return, isn't it? And then we can sort our answers, because with our intuition we will be adding this first to the answer array, and then this, and then this. Now definitely this won't be in sorted order, so we can just sort it out. Let's look at the implementation code. It is exactly same as what we have discussed. We will have a list of integers as answer, and we are finally sorting it and returning it as answer. Meanwhile, how we are generating the digits, we start with a for loop from 1 until 9 and share it to a method which is generate sequence. We are sending the low and high constraints, answer, and our integer. For with this integer, which is our current, we check if our current is greater than high, then definitely we are not in the bound, so we will just early return it. Else we will check if it is in the bound. This thing is redundant here. I have just added for clarity, because anyways if we are greater than high, we have early returned already, and we will add it to the answers array. We check the last digit by modulo, and if the last digit is 9, right, we ended up with something like 7, 8, 9, right, and we didn't know what to add next. In this case, we do not have a next digit which is greater than 9. That's why we will just return. Whatever we'll add will not be sequential. So we'll just return. We find the next digit by adding the last digit plus 1 to it, and current will increase by 10, and then so on. We go into the recursion to finding the next numbers. Once we have them all, we'll just sort it and return the answer. You can do a dry run to understand the code better. Let's talk about the time and space complexity for this. Here we are running a for loop of 1 to 9, which is big O of 1, right? And here we are just increasing and doing some operations and going to the next digit. How long this next digit can be added? At max we can have 1 2 3 4 5 6 7 8 9, right? This is also not something which is undeterministic or something in n value, so this will also be big O of 1 only. If you think about how many maximum numbers we can have, we are given constraints that's low as 10 and high is 10 raised to the power 9. If we have something of digit of 2 length, then we can have numbers like 1 2 2 3 3 4, total 8 numbers, right? For thrice of length, you can do this exercise and you will find out all these numbers are actually 7 numbers. So for twice of length we get 8. For length is total number of sequential digit integers, how many we get, I'm just writing it. 3 we get 7, 4 we get 6, and similarly if we have 9 length we get 1. If you will sum them all, then you will find out its totals out to be 36, which is not a huge number and which is very deterministic and big of 1. And with the space also, if we'll think about the stack space, that will also go to that same length, right? So here our space and time complexity is big of 1. While thinking about a previous approach, you must have thought, okay, it's about length of the lower bound and the upper bound. Definitely we can have a second approach which is based on these lengths. We can create a string of the sequential numbers and we can have our lengths. So let's say our lower and upper bound is something like this. We can run a for loop of length which goes from the lower length until higher length. For example, it was 1000, so the length of this will be 4, right? So we can have digits up till like 4-digit number, and similarly we can have 10 raised to the power 9, so this can go up till like 10 digits, something like this. And for each of these lengths we can start with the 0th index here. For example, it was 4, so we can have number until here and check. If it is under the bound, we can just add it. Next we can slide the window ahead, and then we can check the same thing, and we can slide it more until we reach here, right? Because if we'll slide it a little bit more, we are going out of bounds for the length. So we can have another window which is I, and it can start from the 0th until our I plus the length, right? And for each of this we can check. If it is in bounds, then we can add it. If you see closely here, we are like starting with the same length same length integers, so these will be sorted also. So our concern that we have to sort it later, that will also be resolved. You may try to implement it. Let me know in the comment section. If you need a code for it, I'll provide. Thank you so much for watching.